Dear students, welcome to the course on Fluid Mechanics and Hydraulics. Fluid mechanics is that branch of engineering science which deals with the behavior of fluids under the conditions of rest and in motion. As we all know, matter is divided into two, that is solids and fluids. And these fluids are again classified as liquids and gases. So fluid is a substance which is able to flow or which will continuously deform under the action of an external force. And mechanics is that branch of engineering science which mainly focus on the movement of material bodies. And if this material body is in the solid state, we'll call it as solid mechanics. And if it is in the fluid state, we'll call it as fluid mechanics. So here we'll be mainly dealing with the behavior of fluids. Next we'll see different fluid properties. And the first property is density of the fluid. We'll also call it as mass density. Mass density is the quantity of mass that is occupied in unit volume. It is the ratio of mass of fluid to its volume. We'll express density by the symbol rho. So density is the ratio between mass of the fluid and its corresponding volume. Now we'll see the unit of density. Unit of mass is kilogram and unit of volume is meter cube. So we can write unit of density is kilogram per meter cube. Density is an absolute quantity. That means it does not change from place to place. It is a constant. And density of water. Water is considered as standard fluid and density of water is 1000 kilogram per meter cube. Here you can see 3 containers of equal volume. And in case of solids, the intermolecular forces of attraction is very strong. The molecules are closely spaced. And the force of attraction is less in case of liquids and even less in case of gases. So in case of solids, the density will be very high because we can occupy more quantity in the same volume. So when the quantity of matter present in the volume is more, the density will be high. Next we'll look on to another property, that is specific weight or weight density of the fluid. As the name indicates, it is the weight of the fluid per unit volume. Specific weight is expressed by the symbol gamma. So we can write gamma is equal to weight of the fluid divided by volume of the fluid. So now the unit of weight is Newton and that of volume is meter cube. So the unit is Newton per meter cube. And we all know that weight is equal to mass into acceleration due to gravity. So here we can express specific weight as mass into acceleration due to gravity divided by volume. So here this mass by volume is nothing but density rho. So we can write gamma as rho into G. Gamma is equal to rho into G. Now we will calculate weight density of water. We know that density of water is 1000 kilogram per meter cube and acceleration due to gravity is 9.81. So weight density of water will be 9810 Newton per meter cube. So density is 9810 Newton per. Next fluid property is specific gravity, and we'll express by the symbol S. Specific gravity is a ratio of weight density of the fluid to weight density of standard fluid. In case of liquids, the standard fluid is considered as water, and in case of gases, air is considered as the standard fluid. So we can write specific gravity of liquids will be weight density of liquid divided by weight density of water. So weight density is expressed by gamma, gamma of liquid by gamma of water. And we know that gamma is equal to rho of liquid into G divided by rho of water into G, and this G and G will get cancelled. So we can also express specific gravity as mass density of the fluid divided by mass density of standard fluid. Similarly, in case of gases, weight density of gas divided by weight density of standard gas, that is air. Okay, and we can rearrange this expression. That is, from here, mass density of any liquid will be specific gravity of that liquid into mass density of water. Similarly, weight density of any liquid will be specific gravity of that particular liquid into weight density of water. For example, specific gravity of mercury is 13.6. And we know that mass density of water is 1000 kilogram per meter cube. Mercury is a liquid, so we need to consider standard fluid as water. Okay, so from this we can calculate density of mercury. Density of mercury will be specific gravity of mercury into density of water, that is 1000. So we will get it as 13600 kilogram per meter cube. Now we will calculate specific gravity of water. So specific gravity of water will be weight density of water divided by weight density of standard fluid, that is water itself. So specific gravity of water, we will get it as 1. Now, what will be the unit of specific gravity? Since it is a ratio between two densities, specific gravity is unitless. It is a dimensionless quantity. It is a dimensionless quantity. Now we will try to solve a problem on fluid properties. Here we need to calculate the specific weight, mass density and specific gravity of a liquid having a volume of 6 meter cube and weight of 44 kilometer. Now we will take down the given data. Weight of the fluid is 44 kilonewton, that is 44,000 Newton. Volume is 6 meter cube. So first question is to calculate specific weight. Specific weight or weight density is expressed by gamma. Gamma is weight by volume. So we will get it as 44,000 divided by 6. That is equal to 7333.3 Newton per meter cube. Next question is to calculate mass density. Mass density is nothing but rho. Rho is equal to mass by volume. We know that gamma is equal to rho into G. From this, rho is equal to gamma by G. Gamma is 7333.3 divided by G is 9.81. So we will get density of the fluid as 747.5 kilogram per meter cube. Next we need to calculate specific gravity of the fluid. Specific gravity S is equal to gamma of the fluid divided by gamma of water. Gamma of fluid is 7333.3. Gamma of water is 9810. So while solving, we'll get it as 0.747.